All right, let's get started. All right, so you have your next assignment out due Thursday or Friday if you use one of your late days. Any questions or problems about the assignment or anything else? Yes?
You are string through a scanner, does that break into something, or do you need to character that
You say if you run a string through a scanner, create a scanner from a string, does it break it into characters, or can it break it into characters? I'm not sure, but if you want to break it into characters, I'd just iterate through the string. You don't need the scanner. Okay. Stefan wanted me to tell you that the refresh rate, so you're doing half of the assignment is to create an animation, and there's a refresh rate set in one of those files, and it's set to 5, and it ought to be set like to 33. So it's refreshing more quickly than your monitor is, so it's sort of wasting effort. So if you want to change that to 33, might be a good idea. So the animation, you know, it's up to you. I have guidelines as to what we want to see at a minimum. The thing about the animation is what you're drawing are frames. So what you do is draw a static scene over and over again, slightly different. So you don't have to know how to do animation. You have to know how to draw pictures. And you had a lab where you drew some pictures, and it's just a matter of figuring out what methods there are to draw on a graphics object. So it's meant to be fun, not difficult. So some people do really amazing animations. Others just do the minimum. Either way is okay. Any other questions? All right. I wanted to take a few minutes here to sort of see where we've gotten so far in the course. Now the course is about, I don't know, close to a third over. So here's terminology that I'm using. I may have, I don't know if I defined it before, but now you have enough experience, we can certainly talk about what these things mean. So we've been studying a programming language, namely Java. And a programming language is a formal language for describing computations to computers and to people. What's formal about it? Yeah?
It has a very specific defined syntax. You can just type whatever in place.
Okay, so it's a formal language because it's not free form. There's a very strictly defined syntax, and you got to obey that syntax or you can't do anything. It also has a very carefully specified semantics. Semantics is a synonym for meaning. So that's what we mean by formal. And if that's what a programming language is, then a computer program is a description of a computation written in a programming language. So with a computer program, it ought to be understandable to a person, and it ought to be understandable to the computer. And beginning programmers have trouble with the understandable to a computer part. Some people go on and get good at that, but stay really lousy at making sure that their programs describe computations to people, that people can understand their programs. So both are important. It says there what a programming environment is. Have you seen a programming environment? Okay, so Eclipse is a programming environment, and there are many programming environments. I'm pretty sure I haven't defined the term interpreter, but an interpreter is a tool, typically, it could be a program, that examines a program and carries out the computation it describes. So an interpreter, a Java interpreter would be something, perhaps another program, that looks at a Java program and carries out the steps it says to carry out. Now, another tool is the compiler, and I know I've used that word, probably haven't defined it either. It's a tool that translates a program from one language into another. Now, when is your program compiled? When does this translation take place? Well, he said at runtime. Actually, it gets compiled. It gets compiled in several steps. What I'm thinking happens sooner than that. Yeah? Right. He said it's always compiling. So it's constantly trying to translate what you have into something else. And most of the time, it can't do the translation until it makes sure there are no errors in it. So the compiler is constantly showing you errors. Now, when I learned to program, we didn't have any trouble knowing when the compiler ran because we would write program just in a sort of in something no more powerful than Notepad or something, just a plain text editor. And when the Spirit moved us, we would compile it. And then we would get printed out on the screen or a piece of paper a list of errors to fix. And then we go try to fix the errors and compile it again. Sometimes it could take minutes to compile just what you think of as a small program. So the compilers were slow. All right, let's get started again. All right, I just learned my audio wasn't working for most of that, so good thing you're here. I got new batteries in now. Hopefully it's working. Back to our array examples. Okay, here's there's something else I wanted to show you. I did it two ways here. So this is doing it with a while loop. You've seen this before. This is the same thing with what's called a for loop. So let me explain how a for loop works. For loops are very commonly, almost exclusively, they're always used for processing arrays and lots of other things, just because it's more succinct. You can see that's fewer lines of code than this. Okay? So this is executed once, exactly once, before the loop runs. So that would declare a variable I and set it to 0. This is the test that's evaluated each time around the loop to decide whether to do the loop. And this is done after every time after all the statements in the body have been executed. It said reconnection successful. So it's tough enough to teach a class, being a video producer at the same time. All right, and you can see down here the while loop. We set that happens once. This test happens every time at the top of the loop, and this is done at the bottom. Yep.
I think you touched on it before, but what's the difference between I plus 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 plus?
If you put them, he's asked what's the difference between I plus plus and plus plus I. If you put them on a line by themselves as a statement, there's no difference. And if you use them not on a line by themselves, you need to know a lot more than you do right now. So I'm going to leave that alone. I can explain after class to anyone that really cares to know. But if all you're doing is saying I plus plus all by itself, then works great. Okay, so that's just a for loop, and we'll use them a lot. You'll notice when I gave the equivalent while loop, I put the while loop inside braces. The reason I did that is this I is not visible in the for loop. This I is not visible outside the loop. And by putting braces around the whole thing, that prevents this I from being visible anywhere else except in the vicinity of the while loop. But we'll tend to use for loops. Any questions about for loops? Very easy once you've written one or two, as long as you can write while loops. Here's a method called make random array. And make random array takes an integer and returns an array of size n and fills it up with random integers. So if you pass in 100 as a parameter, then you're going to get back an array of length 100 containing random integers. The random integers are all less than 1,000. So let's see how that works. What's going on right there, where I've highlighted? All right, I have declared a variable called random array, which is an integer array, and I have created a new array of length n and stored it in the variable. So that's array declaration and creation all in one statement. So whatever n was, I've got an array that size. Then I have a for loop that just runs through the indexes of the array from 1 up to but not including n, or from 0 up to and not including n. And each time through the array, I store into random array sub I a new random integer. So rand is a random number generator in the Java library, and it just picks a random integer, and that gets stored into the array. So this will create a randomly initialized array of a particular length. So that does some things we didn't see before with arrays, how to create one, and how to store something in one. And that's just about all there is to know about arrays. Let's look up here where I used it. So up here in main, you can see I create an array called integers by calling make random array, so that'll be stored there. And then I want to sort them. So there is a class in the library called arrays, which has a variety of static methods that operate on arrays. And one of them is sort. So the sort method will just arrange that integers array into ascending order. And then we're going to print it out. Now, arrays don't have a toString method, but the arrays class, with a capital A, does have a static method called toString that'll take an array and turn it into a string. So let's run it and see what gets printed out. And there's where it gets printed out. So it created a random array and then sorted it, and there are the numbers for this run. They'd be different every run in ascending order. So before you go and try to, if you need to sort something, an array, it's good to know there's a method that'll do it for you. And there are other methods that'll search for something in an array and various other things. So be sure and look at that arrays class to see what there is. All right, one more example, right down here. I have a method I wrote called display folder contents. And what we do is we give it the full path name of a folder on my computer. So it's C:\users\Zachary, so on. So this is the name of the folder that contains today's project. And then what the method does is it prints out all the things that are stored in that folder. Now, why do I use double backslash here? Backslash instead of just a single backslash? Yeah. Well, in Windows and DOS, backslash is used to separate folders, but why two of them? Yeah. Right. When you want to escape something, like \T means tab, \N means new line. So if you really want a backslash, you got to do \\, unfortunately. So let's look at how the method works. So let's see. First thing I do is I take the folder path, which is a string, and I turn it into a file object. So there's a file class in the library. And then I'll call that folder. So folder is now a file object corresponding to that folder. And then I can ask the folder to give me back all the files it contains. And what does list files return as its result? Yeah? An array of files. You just look right here and you see, okay, an array, of file objects, whatever they are. Great. And now we can loop over, here's a for loop that loops over that array and prints them out. So we generate all the i's here. For each i, we pull a file out and we print it out. And there's a toString method that will convert the file to a string. The string is just the name of the file, the path name of the file. So when we run it, we get, here they all are printed out. So that's everything in there. I'm printing them out twice. That's why you see them twice. So we didn't have any choice about using arrays here. That's just what list files does. It returns an array. Now, here's another shortcut. This is called a for each loop. Even shorter than the for loop. So that's a good one to use as well. So let's see how a for each loop works. So a for each loop will only work for certain types of things. And one of those types of things is an array. And as we learn about other types of things you can use a for loop for, I'll tell you. Yeah? Always. Yep. I told the TAs, in fact, that if you call a TA over to ask a question in the lab, I want them to look and make sure that you have all my lecture examples on your laptop or on your computer. And what they're supposed to do is not help you until you do that, because you need to look at these examples after class. So yeah, the plugin, it takes me a while after class to get them up, but the plugin will download them for you. Okay. So That has to be something that you can write a for each loop for. An array is such a thing. That there has to be the type of thing that's in the array. So contents is an array of files, so that's a file. F is a file variable. And then all you have to do is put that colon there. So you say for, and then in parentheses, file variable, comma, file array. And each time through the loop, F gets the next thing in the array. So you don't have to mess with the indexes. The for each loop takes care of that for you. Down here, you had to manually generate the indexes, pull the file element out, and then do the thing. So the loop is taking care of the indexing for you. Okay? Yes? No. F is a reference to the same object that was in the array.
So let's say the array is int, and you just say f equals 3, but that's index 3 equals the array?
No. No, you change the assignment changes the value of a variable. All right, I see what you're getting at. This is useful if all you need to do. If, on the other hand, you need to write a loop like we did up above that stores things in an array, you can't use a for each loop. For each loop is exclusively for just quickly iterating through all the elements in some collection. So if you need the index in order to do this, you can't use a for each loop. Okay, any other questions? Yeah. It's just, what does contents mean? It's just that array right there. I declared, so I created a file object. I asked the file, which is actually a folder, to give me all the things it contains. And what I get back is an array that I called contents. And then I just iterated through the array and printed out the names of all the files. Yeah? Sure, if you want to use either of these kinds of for loops on the current assignment, feel free. I don't think you can use the for each in the current assignment because there are no arrays in there. You can certainly use the for loop. Basically, if you're iterating over a string or iterating over an array, use a for loop. That's what everyone else does. Yeah?
Within the contents array, is a folder treated as a file or as a folder that can be opened?
Well, what Java calls a file can be either what you think of as a file or what you think of as a folder. It's just something stored on the file system.
So it would just be the first layer down.
Yeah. Right. When you ask what's in a folder, you just get, it's not exploring all the way deep. It's just what's contained in it. Okay. Now I'm going to look at something different. Exceptions. So let me do a little demo for you here. I have some slides that talk about exceptions in the abstract, and you can look at those later. But a lot easier to explain if I just show you how exceptions work. Now, how many of you have ever seen a Java program have an unhandled exception? Okay, the rest of you put your hands up. I don't believe that any of you have never seen an unhandled exception. If you've had a program crash, it's because there was an unhandled exception. All right, so you may not have known it, but you've been dealing with exceptions since the beginning. So let's look at this program. I call a method called convert1, and I pass it a string, and it's supposed to convert it to an int and return it, and then I print it out. Convert1 takes a string. It calls convert2 to do the conversion. Whatever it gets back, it multiplies by 4 and returns that. Convert2 calls convert3 to do the conversion, multiplies what it gets back by 3, and returns that. So this is just all silly. Convert3, finally, whatever it gets in, it does the conversion, multiplies it by 2, and returns it. So I have a reason for doing it this way, and I'll show you why. So the way to think of it is main calls convert1, which calls convert2, which calls convert3. So what I'm going to do Well, this is what I'm going to do is I'm going to leave that. I'm going to put a breakpoint there, and I'm going to run it in debug mode. All right. And as you learned this in the lab last time, so it's in debug mode now, and it shows you where it is. It's on line 7. It's getting ready to call convert 1. So I'm going to click step into, and it calls convert 1, and now convert 1 is ready to call convert 2. I will step into that, and I'll step into that. So at this point, if you look at this window up here, what you see is the main method got to line 7, and it's waiting to execute some more, but in the meantime, it's waiting for convert 1 to return. Convert 1 is sitting on line 13, waiting for convert 2 to return, and convert 3 is on line 27 at the breakpoint. So as I'm going to step through this now and watch what happens to the stack trace up there. This is called the stack trace. It shows you which methods have called which methods. So I'm going to call int parse, and you say I've gone to line 28. I step over, multiply by 2, and then I'm going to return. I'll step out. Keep your eye on the stack frame up there. That highlighted stack frame is about to disappear. Okay? Because that method's done. And now I can see the variables over here for that frame. In fact, if I want to see convert 1, I can click here and I can see, okay, back in convert 1, S is 5673. Here in main, I got that. Okay? I'm going to do the conversion, multiply by 3, return. Now the stack trace just has 2 things on it. I will do the conversion. I'll finish doing the conversion, multiply by 4, and return. And I'm back in main, and I take the result and I print it out. Okay? That's how things work. Method calls method calls method. Return, 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 return. So a method that's waiting for another method to return something is sitting on the stack, taking up space until the method it calls returns. Now, let's do this a different way. I'm going to put something that's not an integer. So that will not be able, when we finally get down here, parseInt will not be able to parse it. The question is, what does parseInt do when you give it something it can't parse? Let's see what it says it does. It says if the string does not contain a parsable integer, it throws a number format exception. Okay, so let's try this out. I'm going to run it in debug mode. I get to here. I will step in, step in, step in, and now it's about to do the parseInt. The problem that's going to happen is it's not going to be able to parse the string, and instead of returning, convert 3 is going to throw an exception. So throwing an exception is an alternative to returning. A method either returns or it throws an exception. Either way, it will terminate the method. So here I'm going to step over it, and program's over because the exception was thrown. And if we come down here in the console, there you see this is the stack trace that existed when the exception was thrown. So it says up here, exception in thread main, number format exception was thrown because of string 5763x. And if you read down, or read up, it says main was on line 7, convert 1 on line 13, and so on. Convert 3 was on line 27. Then you get into the system methods. ParseInt was on line 615. Another parseInt was on 580. And finally, the exception was thrown on line 65 of the number format exception class. Anyway, you can click around in here and find out what went wrong. You know what exception was thrown. You know what triggered the exception because it says right there. If we click on the stack frame to convert 3, it'll show us where the exception was thrown. So when your program dies because an exception was thrown, you don't have to just say, oh, it died, I don't know why. Look in the console. You can look at the stack as it existed when the exception happened, and you can go look at the code and see what caused it. In this case, we see what caused it. We passed parseInt something it couldn't deal with. So that's what an exception is. An exception is sort of an abnormal, doesn't have to be abnormal, but sort of an unexpected or an unusual termination to a method. And if you don't deal with an exception, if you don't catch the exception, then the program crashes. But you don't have to let the program crash. So let me first see, before we see how to deal with this, let me see if there are any questions about what throwing an exception, the consequences of an unhandled exception. If you don't take anything else away today, take away this fact that if your program terminates unexpectedly because of an unhandled exception, you can look in the console and figure out why. You can trace back what happened. Usually the place to look is the first stack frame here. That's your method. So yeah, parseInt, that's not your method. Convert3 was my method. So look and see, that shows you where the exception was thrown. Let's see what you can do about it. So there's a lot to say about exceptions. Let's just see how to handle. Now, I didn't put any JavaDoc in here because I was in a hurry. So let's just say returns the result of converting s into an int. If s can't be converted, what should we do? Let's just say returns -1. That's probably not that great of a choice, because what if the thing that we're converting happens to be -1? But just for the sake of illustration, let me just show you what you can do. We know that if garbage gets passed to parseInt, it'll throw an exception. One thing we could do is check and see if s contains garbage before we call parseInt. But how can we? What's a way of telling whether s is going to parse properly? Yeah?
Use the try.
Well, if we're not talking, except with exception handling, I don't know of a method that says, integer.parseInt. The way I find out if a string is going to parse is to try and parse it. So to handle an exception, you use what's called a try statement. You wrap try around a block of statements, and then you can catch an exception. Incidentally, I've heard from several students, number of students, that the last thing they do before they hand in a program is format it, because they don't want to lose points for formatting. Why do I ask you to format your program? Yeah? He said to make it easier for people to read, in particular to make it easier for you to read. Yeah? Develop good habits. Yeah? Okay. Well, all these are good answers. The bottom line is, what I'm saying is, if you are keeping your program completely unformatted until the last step when you hand it in, you are completely missing the point. You can learn, if you always format your programs consistently, if you have a syntax error, it's going to be obvious to you. You'll notice the formatting is off, and it makes it easier to tell something is wrong and where the problem is. Get in the habit of keeping things formatted. I can't stand to keep things unformatted for long. Yeah? Okay, let's break down this try statement. So you say try, and then you have braces, and it contains some statements. What this says is, if, while executing these statements, a number format exception is thrown, immediately, instead of crashing the program, the catch block is executed. This says, if a number format exception occurs in this block, transfer control right here. So instead of it crashing the program, what will this method do instead of causing the program to die? It'll return -1. E is the exception that was thrown. So what I'm going to do now is I'm going to remove the breakpoint here. I'm going to set the breakpoint here, and I'm going to run it, and we'll see what the try block does for us. Okay, we're here, and if I execute a step, that's going to cause the problem. So the exception was thrown and caught. Okay, throw and catch go together. And now we just execute the return, and -1 will be returned. Now the question was, what is E? Well, there's E, and we can look up here. There's E. It's a number format exception object. And if you look into it, you can find, there's the detail message. And you can even, if you wish, it contains a stack trace in it, so you can go explore the stack trace. Usually you don't do anything with that object, you just ignore it. Yeah? Oh yeah. Yeah, you can. I'm just in the habit of calling it E, because normally I don't care, I don't do anything with the object anyway, so I just call it E and ignore it. Yeah? You can have multiple catch statements. So if you think that there may be a number format exception, or maybe there's an exception called array index out of bounds. So you could, there's one called runtime exception. So you could have another handler here that said, okay, return -2 in that case. Okay? Yeah? No. No, you don't have to put throw. We're not the exception is being thrown by this method. So inside parseInt, there's a throw. ParseInt didn't handle the exception, so we get the chance. Now, if we didn't handle it here, you have the option. You can put a try block up here that catches number format exceptions, and you can catch it at that level. Because this last point I'll make is, if this method does not handle the exception, this one gets the chance. If this doesn't have a try block to handle the exception, then this one gets the chance, and so on all the way to the bottom. It's only if there's no handlers all the way back to the beginning that the program crashes. All right, we'll say more about this next time.
You believe?